Tonight's lesson is on how to put numbers into scientific notation. Now you've already worked with when a number is given in standard form, putting that into scientific notation. For example, 637 million. You know how to write that in scientific notation. You just say to yourself, okay, where does the decimal point start? Well, in a number larger than 1, it's always then at the end of the number. And then you say, okay, I have to move my decimal point so that my first factor can be between 1 and 10. So we move our decimal point there. How far do I move it? 1, 2, 3, 4, 5, 6, 7, 8 places. It's a number that starts at greater than 1, so I know it's a very large number, so I know my exponent is positive. So my first factor has to be 6.37, a number between 1 and 10, and my second factor is 10 to the 8th, because I had to move that decimal point 8 places. And I know it's going to be a positive 8 because I start with a number greater than 1, so it's a very large number. So either way, that represents 637 million, and you should be comfortable with that at this point. But tonight, we're going to be able to take a number written in any form and rewrite it in scientific notation. We're going to take a look at numbers like this, 63.7 times 10 to the 7th, and you're going to be asked to rewrite that into scientific notation. Some of you are looking at that number saying, why is it not in scientific notation? Well, look closely. What do you notice about the first factor? 63 doesn't fall between 1 and 10. So 63.7 times 10 to the 7th, in scientific notation, it would have to be 6.37 times 10 to some power. I'm not sure what yet. This is how I handle it. You'll have other strategies, and we're going to give you some more strategies this evening. But for me, I'd say, okay, 63.7, my decimal point was here, and my exponent here is 7. I'd want to move 7 places right. Well, if I want to move this one 7 places to the right, and I started here instead of 7 places to the right, now starting here, I'd have to move 7 and 1 more, 8 places, because I'd have to move this 1 place and then 7 more, the way the decimal point, the exponent tells me. So here, instead of 63.7 times 10 to the 7th, it's 6.37 times 10 to the 8th. All right, let's take a look at another one. And again, we're going to give you strategies tonight. So if I look at this number, 0.00637 times 10 to the 11th, I know this is not yet in scientific notation, and it's because of that first factor again. That first factor isn't between 1 and 10. So I'd say, oh goodness, I need to put this between 1 and 10. 6.37 times 10 to some power. And the issue is, what power? Well, if I look at this number, and I know I'd have to move that 11 places to the right, 1, 2, 3, 4, 5, and I continue on 11 places to the right, I'd say, well, if I start it right here, instead of 11 places to the right, I'd only have to move it 10, 9, 8 places more to the right to get to 11. So that's 6.37 times 10 to the 8th. To tell you the truth, all 4 of these numbers are actually the exact same number written in various forms. They all represent 637 million. Tonight we're going to give you strategies so that you can take a number that's almost in scientific notation, but that first factor throws us off, it's not between 1 and 10, and be able to rewrite it so that it is in scientific notation. Let's take a look at some examples. So I need for you to look at the following number. And what you're going to do is you're going to decide, is this written in scientific notation, and how do you know? Look carefully at the number and make a decision. Pause the video, think about it, do a little write-up, and come on back. All right, hopefully you said to yourself, yes, it's written in scientific notation, because that first factor, 3.916, is between 1 and 10. And then you say my second factor is a power of 10. Therefore, you know, because your first factor is between 1 and 10, and it's being multiplied by a power of 10, this is definitely in scientific notation. Oh, yes, it is. So that number we wouldn't even have to work with. It was already in the correct form. Let's look at another number. Look at this number. Do you notice anything different? I want you to look at this number, see if you notice anything different. Try to write up whether or not you think this is in scientific notation. Pause the video and come on back. All right, hopefully you paused the video and wrote up whether or not you think this number's in scientific notation. And you should have said, no, it's not. It's almost in scientific notation, except that first factor is not between 1 and 10. 17 is greater than 10. 17 is greater than 10. That's why this is not in scientific notation. So we'd need to rewrite the answer in scientific notation if we were asked to work with some numbers in scientific notation, maybe comparing them, ordering them, multiplying them, dividing them, adding them, subtracting them. We would first want them in scientific notation, so we'd need to do a rewrite. And how do you do this when the number given is already a factor multiplied by a power of 10? So it's already a factor multiplied by a power of 10. It's 17.1 times 10 to the 8th. Well, the first thing you'd have to think about is you'd have to say, oh, well, my first factor has to be between 1 and 10. So I've got to move that decimal point so that it's between 1 and 10. So instead of 17.1, it's 1.71. Now up here, if I was going to take 17.1 and move it 1, 2, 3, 4, 5, 6, 7, 8 places to the right because of that exponent, if I instead start it with 1.71, instead of 8 to the right, I'd now actually have to go 1 and then 1, 2, 3, 4, 5, 6, 7, 8 to the right. So now it's 1, 2, 3, 4, 5, 6, 7, 8, 9 to the right. So that's times 10 to the 9th. Okay, so you got to remember that. 17.1 times 10 to the 8th is the same as 1.71 times 10 to the 9th. We're going to give you a strategy right now for you to work this out for yourself every time. So we need to remember the steps in writing a number in scientific notation. Step 1, move the decimal point so that the first factor is between 1 and less than 10. So there you go. You move that decimal point so the first factor is between 1 and less than 10. Instead of 17.1, you need 1.71. And if we move the decimal one place to the left, we add 1 to our exponent on 8. So now it's going to actually become 1.71 times 10 to the 8 plus 1. And Miss Pearson actually has a really great way of remembering that. Remember, when we move the decimal to the left, we add the number of places the decimal was moved to our exponent. And here's how Mrs. Pearson helps you remember that. A way to remember this is by thinking of your LA notebook, your language arts notebook. LA stands for language arts, but you can think of in math, LA means left add. So if you're moving that decimal, having to move it one place to the left, if you're going left, please add. That can stand for left add, LA. Now let's take a look at this one. This one's not in scientific notation either because that first number is not between 1 and 10. What would we have to do to move this so it was between 1 and 10? Well, 0.171 we would have to write as 1.71. 1.71 times 10 to the third, 1, 2, 3 places becomes 171. So 1.71 times 10 to the what would still get us 171. Well, now we'd only have to move our decimal point 2 places to the right. 2 places to right still gets us in standard form 171. So 0.171 times 10 to the third is the same as 1.71 times 10 to the second, and both of those in standard form is 171. So let's give you a strategy for this one. Step 1, move the decimal point so that the first factor is between 1 and less than 10. So instead of 0.171, you'd need to move that decimal point now one place to the right. When we went to the left, we had to add, you'll remember from the last screen, left add LA. Well, guess what? Right, we're then, instead of adding, going to need to subtract. When we move the decimal point to the right, you need to subtract the number of moves from the exponent. So in this case, 1.71 would have to, 0.171 would have to become 1.71 times 10 to the 3 minus 1. So if you have to move that decimal point to the right, you're going to want to take that exponent and subtract off however many places you need to move. I want you to go ahead and try a few of these on your own. So take a minute, pause the video, try these out, and come on back and we'll check your answers. Okay, hopefully you paused the video. One way I go about it, this is just me, I say to myself, okay, my first factor has to be between 1 and 10. So instead of 24.3, I know it's going to be 2.43 times 10 to the, well, you can use your strategy. If we're moving 1 to the left, LA, left add, so I'm going to do 4 plus 1, or 2.43 times 10 to the 5th. And that's the strategy we gave you tonight. So if I look at this one and I have to go between 1 and 10, this time to get between 1 and 10, I have to move my decimal point to the right. Left is to add, so then you say, oh, if left is add, right must be to subtract. So that's going to be 6.7 times 10 to the 5 minus 1, or 6.7 times 10 to the 4th. Again, this one, I'm going to take this, and I'm going to move left so that my first factor can be between 1 and 10. And if I'm going to go left, LA, left add, so that's 10 to the negative 1 plus, how many places did I move? I moved 1, 2 places. And guess what negative 1 plus 2 is? That's a positive 1. Right here, I'm going to have to move to the right. So instead of 0.25, I need to make it 2.5 times 10 to the, well, if I had to move my decimal point 1 place to the right, right is subtract. LA, left add, which means right must be subtract. So it's going to be negative 2 minus 1, or 2.5 times 10 to the negative 3. Hopefully those worked out okay for you. Okay, tonight's focus question. How do you know which way to move the decimal point when rewriting numbers not in scientific notation into numbers written in scientific notation? So you have to decide, how do you know what way to move that decimal point? All right, try to have a good night. Do a nice write-up. Thanks. Bye.